We're on page 27, looking at our normal distributions, and we're looking at the probabilities from the left tail of the curve. So that's our area below the mean, and it's down the very bottom left-hand side of the curve. So our example that we've got our backpacks, and we have got our mean of 3.3, standard deviation of 3.3, and we want to find the probability that a backpack weighs less than 2.8 kg. So first step, draw the graph. So here's my normal distribution. Put my mean in the centre, mean of 3.3 and standard deviation of 0.3. Now I'm looking for a probability less than 2.8. So the value of 2.8 on my axis is certainly down below 3.3. So there's my 2.8. And I want the area less than 2.8. So I want this area in the tail, that area below 2.8. So now this is where we've got to think about our symmetry of the curve quite carefully. So for example, when we were to turn this into a standard normal distribution with a mean of 0 and standard deviation of 1, we're going to find the z value, so that little tail area is exactly the same size. Okay, so that our x and our z distributions have the same tail area. But the other thing that we need to be aware of is when we come to use our probability tables, that we've still got our mean of 0 and our standard deviation of 1, but that little tail area on the left there, okay, so this tail area here, is the exact same size as the equivalent point above the mean here. Okay, so that tail there, those two tails that are circled, will be the same size as long as we've got exactly the same z value, just one would be negative and one would be positive. But it gets a little more confusing than that, because what we also need to be able to do is we need to be aware that on our tables, they're going to find us this positive area between 0 and a number. And if we want to find that little tail area, then we've got to remember that the whole right-hand side or the whole left-hand side, that whole probability adds up to 0.5. And if I subtract the blue area that we're going to find from the tables, then that will leave me with that little tail area that we're trying to find. So let's actually just go through and do this calculation and see what we come up with. So we've got, first of all, we've got to calculate our z value. So we've got our, sorry, I'm drawing in the wrong place. Oops. Z equals x take away the mean over standard deviation. So our x in this case is our 2.8 kilos that we're finding. Take away our mean of 3.3 over our standard deviation of 0.3 and put that into our calculator, and that gives us a value of negative 1.667. And that is doing it to 3dp, because remember our table goes to 3dp, so we always want that to 3dp. Okay, so now we've got to think about, well, what does that mean? So that tells us that we're trying to find that point with that tail area of where that z value is negative 1.667. Now that will be the same size tail area if we talk about the positive value of 1.667. Oh, too many sixes in there. Okay, so we're going to, because of symmetry, we can reverse that too. So I could say that the probability that z is less than negative 1.667 is equal to the probability that z is greater than positive 1.667. Okay, so that's just saying that that little negative area, negative small tail on the left is actually the same size tail as it on the right hand side, but we have changed that probability from being the z value from being negative to positive. Okay, so now we need to think, right, well, we still haven't actually found the tail yet. We know that the whole, from the mean upwards, the area is 0.5. So if I was to shade in this whole area there, that whole area would have a probability of 0.5. And I need to subtract from that the actual little, or the part that I can find from my tables. So when we look up on our tables, we're going to find this area here that I'm just shading in this light blue colour. So from the tables, that's the area we'd get. And the tables tell us that that area is 0.4523. So now if I subtract that from 0.5, I'm going to get a probability of 0.0477. And now that is the probability that I want to find. So if we have to write, when we write our answer up in a sentence, we can say, so from our normal distribution, remember we're trying to find that probability of being less than 2.8 kg. We know that that area there, because of symmetry, is 0.0477. So our sentence, we could say, the probability that a backpack, always put it into context, so the probability that a backpack weighs less than 2.8 kg is 0.0477.